So again, the plan for today and tomorrow is to look at analyzing these functions defined by integrals. I already gave you that orange sheet with all sorts of tools that we're going to need to deal with these things. Again, hopefully a lot of this looks pretty familiar to you. But we need to see how to apply these things to our functions defined by integrals. Again, this is a fairly significant thing on the AP exam every year. One of the free response questions is either about this or looking at f prime and figuring out things about f, which is going to involve similar ideas. Also seems very reasonable that that could be a free response question on your midterm exam. So this is pretty important stuff. Let's take a look at problem number 1 in the packet that I gave you. And again, this packet will be our notes for the next, well, today and tomorrow. G of x is the function defined by an integral, the integral from 2 to x of f of t dt. I've got that graph over there, 2 line segments and a quarter of a circle and all that stuff. I want you to find g of 0 and g of 4. And you know what? I think you can probably go and deal with those right now on your own. This is how we started our functions defined by integrals thing the day before break. Remember, the whole point of these functions defined by integrals is the variable is one of our limits of integration. In this case, it's the upper limit. G of 0 should be this problem, which you'll do in a moment. G of 4 should be this problem. Say that again? No, because of how I defined this thing over here. I defined it. It doesn't have to start at the beginning of your function. It's just a matter of where I say you're starting. I hope you didn't do g of 0 the way it was written. What do I hope you did instead? Flipped it. Let's make it negative the integral from 0 to 2 of f of t dt. Negative, it's a triangle, so 1/2 times base times height, maybe negative 2 for g of 0. Brady.
I did it wrong and got the right answer.
How did you do it?
Wrong. I did it f of 0 minus f.
Yeah, no, yeah, that was a really big coincidence.
Oh, yeah.
Don't. What do you have for g of 4? Pi? I think so. G of 4, I'm going from 2 to 4. That definitely didn't work on that one, Brady. Let's see, this is a quarter circle over here, so 1/4 times pi times 2 squared. 1/4 times 4 pi. Yep, that should be pi. Yes? Now, the rest of this. Letter B, I want to find g prime of 0 and g double prime of 0. Well, I feel like I need to do a little bit of work before I get there, and this next piece is really the key to absolutely everything we're about to deal with, so I do need, super focus here. First of all, g of x is the integral from 2 to x of f of t dt. Let me go create a formula for g prime of x. How do you do the derivative of this function? Or what is the derivative of that function? F of x, t? Yeah, this is my second fundamental theorem of calculus that says if I want to do the derivative of this thing, well, the derivative and the integral just cancel each other out. You're going to plug in the x where the t was. G prime of x is f of x. Let's go one step further. G double prime of x will be f prime of x. Okay. If I want to find g prime of 0, g prime of 0 equals f of 0. What does that mean? How would I find f of 0 from that graph? The y values. F of x, those are the y values on the graph of f. So what is f of 0? 0. G double prime of 0, according to the formulas that I created up here, will be f prime of 0. How do I find that from the graph? Slope. Do that. I think I'll make a little comment over here. That's my slope. And it is 1. Rise of 2, run of 2, slope is 1. Do you see how we got those? G double prime means I'm looking at f single prime, which means the slope of the graph that I'm looking at. G prime means I'm looking at f, which is the y values on the graph that I'm looking at. Next thing I want to do. Where is g of x increasing? Well, using your orange sheets, what's the definition of g increasing? G prime is positive. I am looking for where g prime of x is positive. What does g prime of x mean, though? This means where f of x is positive. So what are you... Oh, by the way, I should have finished something off here. G prime, which is f, means I'm looking at y values. G double prime, which is f prime, means I'm looking at slope. G, which is this thing, means I'm looking at signed area.
Signed area, give it a negative.
Say that again?
Signed area, you can give it a negative.
Yeah, but also if you're below the x-axis, remember that thing counts as a negative signed area. So we've got 2 reasons it could be negative. Back to letter C. Where is g increasing? Well, where g prime is positive, but what you really care about is where f of x is positive. What are you looking for on the graph? Positive signed area, positive y values, positive slopes? Y values, because that's the f of x that I care about. Let's see. Where is f of x positive? I think here. I think here. I think there. I think I'm going to say between 0 and 4, and then between 4 and 6. No, because, well, that would be fine. It would be fine. Eliza. Because technically at x equals 4, g prime, which is f, is not positive, it's 0. So I need to justify this thing, and I feel like I already sort of did that over there, but we need to justify it like after we give our answer. So what I'm going to say for my justification is because, and this next step is important, our justifications need to make the connection between f and g and those things. So, because g prime of x, which equals f of x, is positive. That's what I'm going to be looking for a justification. G prime is positive is our definition of g increasing, but f is positive is how I'm going to use the graph that I'm looking at. And the justifications need to connect g and f. Questions? Turn the page. I think just for fun, I'm going to get those formulas up here again. G of x equals the integral, just so I don't have to keep flipping between the 2 pages. critical values of g and determine if they're relative minimums, relative maximums, neither. Critical values occur when your derivative is 0, or undefined. So I'm looking for where g prime of x is 0 or undefined. Which means, how am I going to use the graph to figure this out? Where the y values, and I think I want to say where f of x equals 0 or is undefined. Find them, please. And yeah, as Kevin and Brady and I think others said, we're looking for where the y values are 0. Where f of x equals 0 or is undefined. Because again, always making that connection between the g's and the f's. I think there are two. First one, 0. Then x equals anyone have an idea, raising your hand, what 0 might be? A maximum, a minimum, or neither? One hand. Okay, Brady.
I said it was a relative minimum.
Correct. Why?
Because g prime of x is equal to f of x, which goes from negative to positive.
Exactly. Because g prime of x, which equals f of x, changes from negative to positive there. We're looking at g. We're looking at g prime, which is f, which is the y values on the graph that I'm looking at. So yeah, my y values are changing from negative to positive at x equals 0. 4. What was that? Why? Yes. So it says justify. I do have to justify the neithers as well, but I can. It is neither because g prime of x, which equals, it's still a critical value because g prime, which was f, did equal 0 there. It just happens to be a critical value that is not a max or a min. Doesn't change sign there. Meg. Okay, so I guess on one of these, it wouldn't really be an issue if you had f and wanted to know the graph of f and wanted to know where f prime is undefined. Well, that would be the sharp turns and vertical tangents and things. I guess it would be places where f is not continuous, so having a vertical asymptote or having a jump or just having a hole on that graph. This is my definition, but don't expect that to really matter so much. You're really going to care about the g prime, which is f equaling 0 rather than being undefined. No, so what's going on at x equals 4? A g prime of 4, which is f of 4. What is f of 4? F of 4 is 0 because that's the y value right there. F prime of 4, which is really like g double prime of 4, that's the one that's going to be undefined. Do you see the difference? Okay. Anything so far? Moving on. X coordinates of inflection points of g. Definition of a point of inflection of g. Get that from the orange sheet. Points of inflection happen where? What happens? No. Not f double prime changes sign. I don't want that yet. I definitely don't want that yet. G double prime. Definition of g having a point, and that's actually important that we're talking about g double prime rather than f double prime because they mean very different things. We've got two very different things going on here. I'm looking for where g double prime of x changes sign. You know what? I'm changing my mind on this. I want to actually do F before we do E. There's a reason for this. Skip, we didn't say anything wrong about E, but I want to go on to F, and then we're going to come back to E. Letter F. Where is G concave down? What's the definition of G being concave down? Definition. G double prime is? Down? Negative.
Oh, it's just which way they go.
G double prime is negative. Which means what am I looking for? Well, hold on. Give me the connection first between G and F. Where F of X is negative? Well, hold on. G double prime, according to our formulas, equals what? Doesn't equal F.
F prime.
F prime. So I'm looking for where F prime is negative. I'm not... yes, I'm going to think about slope. I just don't want to quite state that yet. Now I have the graph of F. I want to know where F prime is negative. Yes, that means where the slope on the graph of F is negative. So go figure that out. And then we actually have to talk about the justification because I messed up a little bit a month ago. Not messed up, I just... the College Board wants a little more than what I had you write before.
Oh, no.
Yeah, okay, you can do that, but this is not a huge thing. What do you have for an interval? Hands. Hands, maybe? Any new hands, maybe? Maggie. 2 to 4? I like that. Because F prime, the slope of F, is positive there. I'm liking... no, is not positive there. Is negative there. Yeah, I'm liking 2 to 4. As far as the justification goes, we're going to say because. How am I going to start this? Not G prime. G double prime. Okay, we can say the of X. I don't even need that, but that's okay. Which equals? I don't want slope yet. F prime of X is negative. That's everything we kind of dealt with before. There's actually another piece that they're going to want. But before we do that, any questions so far? Again, you got to have that connection between the G and the F's there, and it's really important which one is the double prime and which one is the single prime. It means something very different if you talk about F double prime. Now, they want all justifications to relate back to the graph that you're looking at. So, we're looking at the graph of F. How do I know where F prime is negative? Well, where F itself, has a negative slope, but the better way that they want you to state is because F is decreasing over there. We're going to add that in as one extra piece, so we don't just connect the G and the F, but then relate our answer to what we're seeing on our graph. That is one extra piece that they are looking for. How do we know F prime is negative? Because F is decreasing there. And the reason I want to do F before E is because I'm going to have to use some similar ideas in letter E for some justifications. Let's go back and do letter E. I'm looking for where G double prime changes sign, which is the same as when what's changing sign? F prime of X. And as far as you're concerned, what are you looking at changing sign? The area, the y values, or the slope? Give me the two places. 2 and 4. Here's where their extra piece gets a little bit annoying. Why is there a point of inflection at x equals 2? Because G double prime of X, which equals F single prime of X, changes sign. And how do I know that? What is happening to the graph of F that you're looking at x equals 2? F is doing what? Not positive, negative. F prime is positive to negative. F itself, the graph you're looking at, changes from increasing to decrease. That's the extra piece they're going to want, and I'm going to want. Because F changes from increasing to decreasing there. I think I needed to give you a little more room, and I'm sorry about that. See if you can deal with x equals 4, writing out the justification the way they're looking for with the connection, but then also how it relates back to the graph that you're looking at. Next year, when I teach this, I'm going to make sure we put that piece in earlier so we don't have to add that in here. It's annoying, but that would be the difference between getting 8 points on a problem or 9 points on a problem, and we can use every point we can get. Oh, let me go load that. Doesn't have to be. Doesn't have to be, but does have to be there in some form. I guess I'm doing that because everything else is how we dealt with things before. This is now just a little extra piece that I'm adding. Okay, so what's my reason? Because g double prime of x, which equals f single prime of x, changes sign. Why? Because f changes from decreasing to increasing there. Questions on this? No, because increasing to decreasing, that's the reason that I've got to write it out twice. If I just wanted change of sign, then it would have been okay to include it for both, but because we've got the difference there. G has nothing to do with really this curve sketching stuff. I want to find the derivative of that thing at 0. What rule do you have to use? The division rule, the quotient rule. Write out your quotient rule, see what you can do with letter G. This goes back a while, but I think we can figure this out. Low D high minus high D low, draw a line, square below.
Are we allowed to use the previous problem?
Sure. I wouldn't call that being lazy. I'd call that using what you've already calculated. Hopefully it becomes a formula like that. G of 0, there are two ways you could do it. You could do the integral from 2 to 0 of f of t dt, which means flip it and do all those things. Or Brady, what else could we do?
Why just took what we found to be G0 from part A?
The other way you do it is you flip back to part A because we already calculated that thing. What is G of 0?
Negative 2.
Negative 2. G prime of 0 is f of 0. I guess we already did this one too, but this is also not super hard to re-find. What is G prime of 0? What was that? I don't think so. I don't think it's negative 1. I think it's 0. G prime of 0 is f of 0. What is f of 0? The y value on the graph that I'm looking at. So I think I have everything I need, and I can say 2 times negative 2 minus 2 times 0 over negative 2 squared, maybe negative 4 over 4, maybe negative 1 for that derivative. And that's our first problem for today. Kevin.
Hypothetically, we didn't have G
then you'd have to do it. Then you'd
solve it even though we know that that part's going to be 0 because it's like the time 0 there.
It would be good to still show what it is, especially because other problems later on, those zeros will kind of cancel in a strange little way. So it's good to show all those calculations. Okay. Questions? I have one more problem we're going to get through today. Turn the page. Oh my gosh, yes. Because one year I didn't do that, go very, very quickly, and they always then said in a particular order which messed up everything. So no. Okay, you know what, before we do this, let's go make some formulas on the top of the page. F of x, I already told you, is the integral from 1 to x of g of t dt. So what's f prime of x? G of x. By our second fundamental theorem of calculus, the derivative of the integral cancel, you're plugging in the x where the t was. What is f double prime of x?
T prime of x.
Okay, tangent line. Before we do anything like crazy, what do we always start from for a tangent line? Like, give me a formula. Y. No, my gosh. Okay. Yes, y equals mx plus b, but there's an easier way. Y, oh my gosh, it's all coming back. Right. Which is usually followed by mx plus b. No, it's y minus y1 and then all that stuff. What do I know right away?
So x1
Yeah.
equals
Okay, x1 is 3. y1. Is y1 f of 3 or g of 3? yf. Because it says I want a tangent line to f of x, which means y1 is f of 3, and m then would be, yeah, let's not say that yet, though. Let's say the easier one first. F prime of 3. Just because now it looks like what we always have. So really, your job now is to find f of 3 and f prime of 3. And I think I'm just going to leave that to you. We've got all the formulas we need on the top. Go find those things. So f of 3 is the integral from 1 to 3 of g of t dt. F prime of 3, by the formulas that I wrote on the top of the page, will be g of 3. What's f of 3? 2.5. I'm going from 1 to 3, not 0 to 3. So as we go from 1 to 3, I'm thinking 1 times 2? 2. What is f prime of 3? Which is g of 3, which is 1, because you're looking at the y value on that graph. So I think y minus 2 equals 1. No, you don't have to say that. Equals x minus 3. That would be the tangent line to that function f of x that I don't exactly know what it looks like, but I know it's defined as this accumulated signed area under that thing. One more. There's a reason you have a half a page for part B. I want to find absolute extrema and classify as the absolute max, absolute min. Absolute extrema means what?
critical value.
Candidates test. Okay, so that's the first thing we need to deal with. I need the candidates test. And yeah, that starts by us finding the critical values of f, which means places where f prime of x, which by the way equals g of x, equals 0 or is undefined. Yes, f prime, which is g, is 0 or undefined. So where is that? Negative 3, 0, 4. We are now going to go and set up our candidates test. Yes, so 4 is both a critical value and an endpoint. They're both going to be included. They don't count as critical values, but they're absolutely going to be things we stick in our table anyhow as endpoints. Yes. I'm going to label it X. What's the heading for the second column? Don't call it Y. G of X? F of X. I want absolute extreme of f of X. I've got to label it f of X. I don't want it Y because Y could be f or G or really anything. No, don't do that. What I'm now going to do is I'm going to fill in my endpoints and my critical values. So I've got negative 4, negative 3, 0, 4. What's wrong? Oh, okay. There's a reason we've got some space here. Although I feel like once we have some, we can kind of base other things on things we've already done and stuff. What is f of negative 4? Well, it's the integral from 1 to negative 4 of g of t dt. By the way, do not just say it's the integral from 1 to negative 4. Make sure there's something inside your integral. They take off for like inappropriately used notation, which means no function inside there. And of course, you're not really going to do this. What are you really going to do? Maybe we'll do this one, and then you'll finish. Okay, let's go. Negative 4 to 1. This first piece. Area is what? Half. By the way, this is inside parentheses with a negative out front. We're focusing, right? Thank you. Then, I'm not going to bother with the trapezoid. How about I just do a triangle over here? Minus a half. Minus 1. Minus a half. Oh, something nice is going to happen, yeah. What's your final answer? Negative. Negative 1. Those things cancel. We're left with the negative 1 inside. Your answer is 1. I need you to go deal with this from negative 3, 0, and 4. So negative 3, you're going to do the integral from 1 to negative 3 of g of t dt. I bet you can take a lot of your work from what we previously did. 0, you'll do the integral from 1 to 0 of g of t dt. And 4, you'll do the integral from 1 to 4 of g of t dt. Take a few moments, work through those sign area things, do show the calculations. And when you're done, remember for absolute extrema, there's a special way we write it. There's an absolute max of this at x equals. We'll deal with that together. Let's just get the table filled in right now. See if your values wound up like mine. Manasa, which one?
No, I just messed the algebra one up.
Okay, 4.
Or
So
shouldn't it be a half plus 2 plus another half?
no, because we're not doing the integral from 0 to 4. We're doing the integral from 1 to 4. Other things. So I guess I take back something I mentioned a moment ago about a special way we write these things. The directions here said give the coordinates. Normally, if we're asked for the absolute max, we would say the maximum value means we would say maybe where it occurred. But because it wants coordinates, I think I can just say coordinates. I've got an absolute max. Where? 4 comma 5 halves, because that's my greatest y value. Absolute min.
0, negative 1 half.
For your homework, the beginning is more second fundamental theorem of calculus, just to review some of that. But 21, 22, 23 are either AP style or directly taken off an AP exam, free response questions based on things like this. Use this packet as models for those things. Everything that's going to show up there showed up in some form over here. Tomorrow, very, very quickly, just to kind of show you where we're going. Tomorrow, instead of looking at like a function defined by an integral, we're going to look at a graph of f prime, figure out things about f, which should seem very familiar. We've done things like that before. But there's a piece of that we weren't able to do before. Let's figure out what f of 12 is. Well, we couldn't have handled that before. We're going to need to make use of some integrals to help us get there, but we're going to save that stuff for tomorrow. I'm going to shut this off.